Okay, perfect. So let's go through the syllabus and see what items are there. We're going to be seeing the course schedule, the assignment, projects, and grade distribution, the communication policy, and the late submission policy of the course here. We also are going to talk about the textbook that we are going to use in this class. All right, first thing first, contact information. You guys have my email address in here. So there are several ways to contact me or communicate with me. So one is the email address. The other one is the course Canvas page itself. So whenever I post something in there or post an announcement or something, there is an inbox feature in Canvas, which is integrated in it. So you just can simply go there and type your message in there, and I will be receiving that message immediately. So email and Canvas are medium of communication. If your question is somehow related to the course and technical material, the project, lectures, and if you think that this question that other students might have, just please post it on the course discussion board. So each week you're going to have a discussion activity for the class. So and for that you're going to be getting some credit. So asking question going to give you some credit. So if the question is related to the course material, please post it on the discussion board so that if some other students have the similar questions in the class, so they can receive a response for the question asked. But if you think that the question is somehow personal and you want to talk about something that is not related to the course, or somehow the thing that you want to discuss with me should stay private, please come to my office hours, and then we can discuss the matter in there. For office hours, the time is from 3 p.m. to 4:30 p.m. on Fridays. And obviously, it's going to be online using Zoom. And please send me an email when you want to have this meeting so that I can allocate a specific time slot during that time. If this time does not work for you for any reason, please propose 3 time slot during the week that you are available. And based on your availability, I will choose one of those time slots that also work for me, so that we can talk about your issue during non-office hours as well. The class information. So classroom going to be virtual on Zoom, as you know. So it's going to be from Thursday 6 p.m. to 9 p.m. But as I said, since this is an online class, the duration of the lecture that we might be having is not going to be more than between 1 hour and 1 hour and a half. So if I talk for like 3 hours, obviously you are gonna feel kind of sleep and bored. Okay, so this is the hours. And as I said, it's not mandatory to attend these lectures. Lecture gonna be made available on course Canvas page. One thing I wanna let you know that the quality of the video and the recording might not be that great. Okay, so please bear with me. And for some reason, the voice quality of this laptop is not that great, so it's a bit noisy. Please don't mind that if you cannot attend. All right. And then you also can use lecture materials from the University of California, Berkeley. So we are gonna be covering same materials. So you can also have an option of using that. Probably I'm gonna be including the link to the video recording as well, so that you have an option of taking a look at my video or the videos. All right, that takes us to the textbook. Main textbook that you are gonna be using is this textbook, Artificial Intelligence, a Modern Approach. The edition gonna be the 3rd edition. Fourth edition is also available at this time, but I've heard that, you know, third edition, you guys might be able to find that the online version of it for a cheaper price. That's the reason I choose this one. The fourth edition, I think, is not available, the online version. But something to note is that it is an optional textbook. I'm going to be providing the lecture notes and this video recording and the lecture slide to you, so that these materials are enough for you guys to, you know, successfully pass this course. But in case you like to have the course in your library, feel free to buy the book, but it is not required. So we have a supplementary textbook as well if you like more hands-on on AI. So this book is giving you more practice AI with Python. That's optional again, but if you want to pursue career in artificial intelligence, this is one of the book that's available. There are some online resources in here. You can click on here and then will be directed to the websites on tutorial on the basic of artificial intelligence. So course description. This course covers many aspects of human intelligence that might be encoded in computer programs. That's the definition from the university website. But I'm gonna be explaining the detail for the topic that we are going to cover in this course just in a minute in this syllabus. So prerequisite. Officially, since you are accepted for the master program, there is no official requirement for the course. But you need you need to be proficient in one of the programming languages. So if you are proficient, for example, in C or C++ or Java, that's okay, because you can immediately transfer those knowledge into Python programming. So the programming languages that we're going to be using in this course is Python. So the project is going to be all implemented using Python. Okay, so course objective, the goal of artificial intelligence. So we have this description. So the course objectives is to tell you the modern algorithm and techniques in artificial intelligence, explaining the theory and technique behind AI, obviously the most widely used one. So we cannot cover everything in artificial intelligence, every topic. So we don't have that much time, but we are gonna cover the most widely used algorithm in AI. So you get the basic in case you want to pursue career, then you can have that base and build on that base and proceed. Okay, grade distribution. This is something of interest probably to all of you. So you're going to be having assignments that's going to be contributing 20% toward your final grade. Then we have discussion activities. This one also going to contribute 20%. Projects are the ones that have more weight in the final grade, in the total grade, so 35%. So we have about like 6 projects. One is just for preparing you to start writing Python programming. And the other 5 are the AI projects. You basically are going to implement Pac-Man game using Python. And the final exam is going to be 25%. So let's see the relation between these different items in this table. So what you're going to be expecting in final exam. So what you should do to succeed in final exam and get the very good grade in final exam. So one thing that I can promise you is that if you do assignments, all assignments, and understand the questions in this assignment, you're going to be passing the final exam, I mean, with a very good grade easily. So I might change, so you're going to get the basic idea of how the questions are going to be. For example, one of your friends give an example about like a traveling salesman algorithm. So, or example. So assume that if you have a traveling salesman, like in one of the assignment asking you about the routes between the source to the destination city, and you have like different cities in between. In the exam, you might expect something like that, but with different, different number of cities and different locations. But the base is the same. So if we ask, okay, so what is the optimal route using informed search algorithm from point A to point, for example, G. So the algorithm is going to be kind of the same class of algorithm. The structure of the question is going to be exactly the same, but the way that the program, the question is going to be presented itself in the exam might be different. It also might be the same. I'm not saying that it's 100% has to be different. So if you do the assignment by yourself and go to the detail of it, and you are happy with what you achieve in the assignment, you're gonna be passing the final exam very easily and get the very good grade. So my objective for this course is that in terms of the result for the student is that everyone get an A. So I kind of arrange all these items in the grade distribution in a way that you guys can easily achieve that. One thing about the project that I want to tell you is that these projects are all designed at University of California, Berkeley. So they have been having an NSF grant for about, I guess, more than 8 years now. They have been working on developing an AI course for a long time. So during that time, they come up with a good platform for creating these projects. These projects, when you complete this project, how you will be graded? The grade gonna be automatic. So it means that there's gonna be a mechanism, a file, a Python file actually, that can test your program. So when you run that, probably I'm gonna be showing that to you during this lecture. So when you run that, it tells you whether your program is wrong or right. So there are some like data defined for the algorithm. So what the program does, it's just fitting some data and get the output from your program, and then this compare those output of your program with the golden results. If you are achieving the same, then you're gonna be kind of passing. So one thing to note is that the program, the auto grader it doesn't care about the appearance of your code. It only cares about the results. But one thing I would like to ask you guys is that just document every line or every important line that you are having in your code. So documentation is very important in programming. Those of you that are software engineer, you know what I mean. Okay, so when you submit your project, you're going to be submitting your source code that mostly going to be Python files, along with the files that come out from your autograder. So autograder gonna tell me that, okay, all tests have been passed, and it's automatically gonna grade you. So I take a look at that autograder. I probably check your source code and run the autograder by myself, and then give you the result. But the aim is for you guys, all of you, to get 100% of the project grade. So you'll see that it's not that difficult. So you're going to be seeing project 0 soon. Some of you might have seen it. And you'll see that it's not a difficult thing to achieve, especially when you guys are 3 together or working together. And also you have the option, if you're not able to get that 100% point, just post the question on the discussion board early in the week, right? So that other student or me can provide answer to that question so that you can get the complete grade. So this is the thing. I'm sure that all of you can get this 35% completely. I'm sure about that. Because the algorithm that's going to be implemented in this project going to be coming out from the lectures, and we are talking about those lectures. And the important point is that you know how to implement them, in a software. All right. So the next thing, how about the assignments? Can you get the full grade on assignment? The answer is yes, and you might ask why. And the answer is that the assignment going to be multiple choice assignment. And the way that I designed this assignment is that, so whatever lecture material you're going to be having from module 2 forward, those questions are going to come from those. And the assignment going to test whether you get the concept of the lectures or not. And also the good thing is that these assignments are multiple choice. So I'm going to give you guys 4 attempts to submit your assignments. So in case in the first attempt you get it wrong, then you have another chance to go back to the question, review the question, and see where your mistake is. So that's a good thing. But one thing I want to recommend is that do not do the assignments just randomly, because sometimes, most of the time, the question gonna have like four answers, 4 choices. If I give you 4 attempts, means that by randomness, you can come up with the correct answer automatically without knowing what the question is basically asking you. With no intelligence, you can get the 20% grade easily in this. But one thing I wanna ask you is that please go through the assignment and understand what's going on. Why? The reason is that your final exam question going to come from this assignment. So if you try this assignment and get your grade, full grade, randomly 20%, and then you're going to be having trouble in the final exam. So I trust you guys first analyze the assignment question, and then once based on your analysis, then you will be answering the multiple choice question. And I'm giving you the multiple attempt option because I do not want to discourage you guys at the middle of the semester because of having a low grade. I want you guys at any point during this course having a full grade in your course canvas page, and by that you kind of encourage to do more. I do not want to discourage you by the grading of the course. That's the objective. So I want you guys get this grade at the end. And the setting that I'm having, I'm sure most of you gonna get it this one. And the other reason that you might be able to do that because of the ample of resources in the setting of this course, information that you can get. So I'm going to be showing you the University of California website to tell you what I'm talking about. Hello everyone again. All right, I see some question in the chat. Still not recording. Okay. So the project 0 should be available to everyone. So let me check that in Canvas and see whether it is published or not. But my aim was to publish that before the semester so that you guys can get an idea of what the mini projects are going to be in this course. So we're going to go to Canvas, course Canvas page. You're going to be seeing whether it is published or not. But I somehow was under the assumption that I have published this on August 14. All right, let's proceed. And any questions so far? Okay.
Yes, I have one actually. You just said that it's an hour-long class, and then it's going to be on activities, right? Those activities have to be submitted right before the class ends, or when?
Okay, so every week we're going to be having a synchronous Zoom lecture. That synchronous Zoom lecture gonna take between 1 hour or 1 hour and a half, depending on the amount of the material that we have for that specific topic. And then after that, Zoom lecture, everyone can go back and start doing the discussion activity during that hour or any day after that hour by the next week, Wednesday. So for the discussion activity, you have time about a week to complete. So it's not required that you stay online, you complete the discussion activity, and then you go. So it is designed for your convenience. You can complete the discussion activity from this day up to next Wednesday at 11:59. And the philosophy behind having a discussion activity is for you guys to discuss your question and issues in that board. So the other student can answer your questions if they can. And if they cannot, then I will jump in and provide the answer and or probably clarify any ambiguity that stay there.
Thank you.
No problem. Okay, let's continue with the student learning outcomes that we're going to be having for this course. The student learning outcome are just based on the topic that we are going to teach in the class. So you're going to be understanding the basic of artificial intelligence, the core fundamental, solve problem using classical searching approaches, and so on. And also, if time permits, we're going to be taking a look at some of the application of all these algorithms in robotics or computer vision. Okay. So this is the list of the lecture that we are going to have during these 16 weeks. So starting from here, lecture 1 is just an introduction to AI. So the reading material is chapter 1 and chapter 2, but you are not going to be tested on this material. This is something just for your own information. So these are the introductory material telling you what the artificial intelligence is, what are the definition, what's the notion of an artificial agent or machine. And mostly we lay down the framework of using the different algorithms and techniques in AI to apply on those environments. They are very informative, so I recommend you guys just read these chapter 1 and chapter 2 if you have access to the book. All right, starting from this week, the project 0 is supposed to be made available like today, but my objective was to make this available 2 weeks ago. Right? Let's see why it's not. So these, let me to have my highlighter in here. Okay, so these things that you're gonna be seeing in here, this means that, okay, the topic gonna be introduction to AI, the reading gonna be related to these chapters, and there's gonna be no homework given to you this week. The only thing that you are supposed to do is project 0, which is Linux Python tutorial. And there is a submission for it. You have to submit some source code for that. And
Professor,
the due date given in another table. Yes.
Professor, I cannot find the project 0 on my canvas.
Okay, yeah, this was a question that one of the other students also has asked. So we are going to have a tour on the course canvas page and see if the project 0 has been published or not. So we're gonna take a look at that, don't worry. So definitely by the end of this lecture, you're gonna be having access to it. Okay, so for example, second week, the topic gonna be uninformed search. It is related to chapter 3 and the section of the chapter 3.1 to 3.4. So you do not need to read all those subsections to understand this. During that week, you're gonna be having access to assignment number 1. Okay, so this is not a due date for the assignment. This is the date that the assignment will be posted. Okay, now that you get the idea, so we are gonna have like about 16 weeks. Last week basically gonna be final exam. A week before that, we're gonna be having a review session on final. So what to expect for final. So the last project number 5, gonna be posted on week 13. Okay. So it's going to be posted in here. Probably the due date is somewhere in here. So let's see the due date. Project and assignment due date. Okay. So this section is related to the due date. So the previous chapter tells you when the assignment is going to be available, and these tables tell you when to submit that specific assignment. For example, project 0, the due date is September 2nd, right? And let's see assignment 1. And assignment 1, the due date is 16 September. And then you have the due date for the project 1 is 23rd of September. So all these due dates are given in here. So if you have a question where the due date is gonna be, you can come back and take a look at the syllabus. In case something happened and you are going to postpone a project due date, for example, then I will let you know through the announcement. Okay, but try not to delay your project, because all these are gonna be subsequent, and if we delay one of these, as you can see, almost every week you have a deliverable. At least the discussion activity is due every week. Therefore, I recommend you guys to do the project and assignment on time, not to get overwhelmed at the end of the semester when you have your final. Okay, what is the due date policy and late policy? So for the assignment, since there are multiple choice assignments, right? The due date is going to be the Wednesday before 11:59, and since these are multiple choice questions, they are not going to be actually extended any day. So if you miss that, since I'm going to be making the solution available immediately a day after, then you miss your grade. So the reason that we are doing this is because we want to, make students to stay on track. And since these assignments are multiple choice, they are very easy to complete. And how about for your project? For your project, you are allowed to have a late submission, but the system is going to be deducting 25% of the credit of the total for that project for each day delay. Just be aware of it. So it is accepted, it's going to stay open, but Canvas is going to, at the end of the day, is going to deduct 25% for each day. If you, for example, miss, you submit it like with 4 days delay, then basically you get 0 credit for it. If I extended the project due date, that's going to be a different story. You're not going to be penalized for it. But if you just delayed like that and it's not extended by me, then you get penalized. Make sure to stay on track for your project and assignment. These are very easy to do. These are very fun to do. Just allocate the time that is required, and you're gonna get the very good grade in this course. I promise you that. Okay. So some of you asked me that, okay, so there are some discussion board guidelines activity. In case that you haven't had any online course before, you're gonna be, participating in discussion board. There are gonna be some rules associated with it. So these are the rules that I have listed them in here. Just make sure to go through them before start doing the activity for any discussions that is coming. Okay, attendance. I encourage all of you to attend, but if you cannot attend in a lecture Zoom, then I'm going to be making this recording available on the course Canvas page, but I'm telling you that the quality of the voice is not going to be that great since I do not have those professional equipment of recording. And unfortunately, this is a Windows machine that I'm using this for this meeting, and the way that it's recorded is not that great. But it's a touch screen, so I can, write on it. That's the reason I'm using this. All right, so learning environment. So just go through this. Some of these university policies are listed here. Just go through them by yourself. All right, so this is it for the syllabus. If you have any question regarding that, please feel free to ask me now.
I had a question. You said earlier that you would make each project, like the details, available to us after the lecture a week before they're due?
Oh, okay. Right? Normally 1 week or 2 weeks before they're due. Okay, so the dates are given all in here. So, okay, so this is the due date table, and this is the posting. For example, machine learning project is going to be posted at week 13 of the course, right? Project number 5. See how many weeks you have to complete that. So, and then it's going to be due that week number 16, and this is the date. Is 09. So basically, it is during the exam period time. So I recommend you, when you're doing your time management, do it like a few days before the week of the final exam, because you're going to have your exam, I guess, the Thursday within the exam week. I'm going to be showing you what the date is. Okay. Let's see. I see that you guys are exchanging your email address. So one thing you guys can do is that you can message each other privately. There is an option for the next to keyword in your chat box. If you choose that, it says privately to person A or C. So you can choose that to exchange your emails. All right. Any other questions regarding the syllabus? Perfect. So let me stop sharing here. I'm going to give a tour. This lecture is going to take a long time. Sorry about that. I'm going to give a tour about the course Canvas page. And then we are going to have the lecture, the intro lecture. And at the end, I want to go to the virtual lab demonstration, basically telling you how to connect to it and what are the simple syntax that you can use to SSH to the virtual server, and what are the most widely used command to exchange files between your machine and the host on the virtual cloud. All right, let's stop this and course Canvas page. For some reason, okay, let's do it again. Okay, guys, I guess most of you are familiar with Canvas platform. And if you do so, can anyone is anyone in the class, is there anyone in the class that she or he not familiar with Canvas platform? Because if you are familiar, then there is no point for me to explain that. If you are not familiar, just let me know to go through that. Just you can put it in the chat box in case you are not familiar with this platform. Okay, so I see that everyone, I'm assuming that everyone is familiar because I haven't received any chat from you saying that you are not. Want to just do this very quickly because we don't have much time left. Okay, so this is the first page of the course. If you go here, so the start here is basically that's the menu that if you click on it, you're gonna go to an introduction to me, and then there is a next button that you click to go to the next part. It takes you to the introductory module. Then in here you will be seeing that what's the expectation for that specific module. Okay, I hope that is correctly linked. And then you have access to syllabus. You click in here, you go to the syllabus page. In the syllabus page, you have access to the syllabus that I just showed you guys. If you click on this, you're gonna be having the syllabus downloaded on your machine so that you can go through it. And these are some also information taken from the syllabus. For example, this one telling you the grade distribution. And then you can back here and go to the course structure, course schedule, telling you, okay, what week gonna happen, what in here, and so on. So if we go back to the home page, how you connect to our virtual lab. So the course module, you can just click on here to go to the course module. Let's do that. You click on this, you're gonna be seeing all of the module here. This is the introductory module. And then we start module 1 here. This is the module that we are talking about that today. So it's introduction. These slides, we are going to talk about that during this Zoom session. And then for your introduction module, you have 2 things to do. One is to submit your learning online badge. It means that you need to go through this course to complete it. It's gonna take 1 hour or 2 hours as university pointed out. And this is a learner information survey. It's like 6 simple questions that designed to gather some information regarding your background, your interests, and probably the issues that you might have personally, so that I know, and then I redesign some of the material according to this review. So this review, if you do this, you're gonna get some extra credit. So let me show you the assignment page. So this is the assignment page. So the assignments are listed in here, discussion activity are listed in here. So the weight that, for example, that class of the homework contributed to final exam are given in here. And I just wanted to use the extra credit activity. Here is the extra credit activities contribute 2% on top of the 100% credit that you guys going to get when you do your homework and project. So a learning information survey is under that, but I ask you please do this so that I know your skills and background so that I can accordingly adjust the rest of the lecture in this course. In case any of you have attended any courses, specifically if you got a degree from University of California, Berkeley, just let me know. But I think I haven't heard anyone to get his degree from there because they are teaching the same course in there. In case you are getting your degree from there, then you can talk to me, and then we can kind of create a customized course material for you, taking you into the next step in AI to do something more in this class if you're interested. And then online badge gonna take 1 hour or 2 hours. Just please do this to get some extra credit. But if you don't do this, it's not going to harm your total grade, but it's going to help me to understand where you are in this course. Okay, the discussion activities are given in here. Module 1 discussion in here. As you can see, the deadline of that discussion, let me just highlight this. So the deadline of the discussion is given here. So when you come in here in your discussion module, you're gonna see the due date. For example, for the first one, module 1 discussion, the due date is September 2nd. Also, you can see the due date for the other assignment. Let me be quick about this. And normally all the things that you need to do are gathered under the module name. For example, in module 1, you need to do a module 1 discussion, and you also need to do assignment 1. I haven't added that yet. I'm going to be adding that after this lecture. And there is no project in here, but remember that, okay, you have to add the project 0 in here. Yeah, project 0 gonna be added in here, but this week, as I mentioned in the syllabus, according to that table, there's gonna be no assignment given to you during this week. This week, you're gonna complete module 1 discussion and project number 0. So it's given at this time, and the due date given in that table. So module 1 discussion is due next week, September 2. The project 0 is due, I guess, in 2 weeks. You will know when you see that. All right. So every assignment and homework under the module is going to be linked in here so that you guys easily know what you need to do. So one thing for sure is that every week you have a discussion due. That discussion talks about the project that you are working on or the assignment that is allocated to that week. Okay, let me see, assignments. I want to go to the project activity, project 1. All right, guys, I have to upload the project 0. For some reason, I've lost 2 things here. One is the learner survey, and the other one was the project 0. I know some of you guys, a few of you actually done the learner survey, and unfortunately, I think I might accidentally remove that from the course list. I'm gonna asking you, please go ahead and complete the learner survey again so that I can have it. But in case you do not want to do it, just let me know that you have done that before, but I don't have a record at this point. There might be a Canvas issue, or the mistake might have been done from me accidentally removing that. All right, so tonight I'm gonna be adding project 0 to your first module. Please take a look at that and start completing the project 0. Okay, this is about this. Okay, the last thing I want to show you is how to access virtual lab. Okay, we have one question in the chat. Let me see what that is. To see that, I have to stop share. Okay, let me just show you the project, and then I will go to the chat box and read your message from there and answer your question. But the way that you can access the virtual lab is in here. You just click on this, and then you come to the lab. So you can click in here, and then you go to the, it asks you to actually input your credential. And after you do that, then it's gonna take you to the lab. Okay.
Professor,
This is the lab. Yes.
Actually, I went to the lab and then I tried to reset my password, and it was like solving for 2 hours, then it stopped. So my virtual machine is stopped right now, and it's not, and the 2 hours are completed.
Your virtual machine has been stopped, so you registered for the course, right?
Yes.
And for some reason, your machine has stopped.
Stopped, and it's showing solving when I try to reset my password. It's showing solving, and
Okay.
it has been stopped.
Okay, so I can take a look at your issue after this class. Just stay in touch with me, okay? So
Sure.
we can have a Zoom chat with each other and see what the issue is. Probably the stop might be, so okay, might be from my side probably. So I'm gonna take a look at that and talk to you about that. So in case for any of you something happened to your lab and your machine stopped, just immediately email me and let me know so that I can restart it for you. Okay, where we were. So we were here. So we said how you guys can actually access the virtual lab. Okay, is it necessary for you guys to use virtual lab? The answer is no. And the reason is that, so I explained in one of the lab that if you're comfortable installing Linux in your machine, right? And if you have a dual boot machine, if you're comfortable installing VirtualBox and installing Linux on top of it, then you don't need to use the virtual lab. So the only thing that you need is a Linux machine having the Anaconda on top of it to manage your Python version, Python version 3.6, and that's it. So this is what you need. You don't need anything specific. So if you're good, if you have Linux on your machine already running, that most of my students have, those students that were with me before, they know how to install VirtualBox and they know how to install like Linux, different Linux distribution on it. So if you know that, it might be very convenient for you to use your own personal laptop or computer, and the reason is that you don't need connectivity for that. But if you want to connect to the virtual lab and use that server in the virtual lab, you need to have a good connectivity. And so if you are not comfortable installing VirtualBox and Linux, the conclusion is that use the virtual lab. Okay, that's pretty much it. We cannot use Python running on Windows machine, PyChar. If you want to use it on Windows machine, so no support will be provided. Okay, so because different platform, different OS system, you're gonna giving different error and issues. So if you're gonna be using Windows machine, then you may not be able to help you because everybody in the class is gonna be using a Linux machine. And in Linux machine, then you're gonna be using Anaconda and then the version. So if you are sure that you're gonna be having no issues in your programming and your project, you go ahead and use Windows. But in this class, the objective is to get you use a Linux operating system machine and use it so that you can also have some practice working with this operating system as a computer scientist. But if you want to use Windows, go ahead and do it, but we can't provide any support in case you got errors in your code or having trouble in between. Any other question? So Darius asked question, are there any specific Python packages needed? So when you go to project number 0, it answers all these questions. Basically, the Anaconda software is a manager for your Python packages. So everything you need, it's gonna be included in the 3.6 Python version. You do not need any additional Python packages. So I'm gonna be showing you at the end of this lecture. Probably I should do that instead of spending time on Canvas. I'm going to be showing that in a moment, like at the end of this lecture, how you can access the lab and how you can use Anaconda to manage your different Python versions. Because you might use, for example, Python version 3.6 in this course, and you might have other courses that use different version of Python. So we do not want to you have the trouble just manually managing this thing. So at one time Python 3.7 and one time Python 3.6. So Anaconda gonna do that. It means that in a single environment, you can have multiple different versions of Python with all packages installed for you. So I'm going to be explaining that in a moment. Okay, so I guess we're done with the Canvas tour. In case you guys have any question about the Canvas tour, just let me know, please. Sorry, this lecture takes a bit of time. So it wasn't my intention to go this far, but all right. So I try to make the introduction part of the course very quick and spend more time on the virtual lab and the Python versioning, packaging, and management instead, because you're going to be doing the lab this week. Okay. All right. Okay, so next topic is we're going to be talking about AI. We basically want to introduce AI, but before that, we want to say, okay, who is this course for? So the way that this course is designed right now is good. It is a survey of AI technique and algorithm for a student with a little exposure to this subject. So it is useful for junior students, senior students, and graduate students. But as I said, if you have passed a artificial intelligence course before, please go to the syllabus. The list of the topic have been given there, okay? And if you see that, okay, you have studied all of these topics and you are proficient in there, and then you are able to do the project in there, just come back to me, tell me that, okay, this is the case, and then we think about different ways for you to complete this course. If this material is going to be, it seems like boring for you, and you know all of them, okay? So prerequisites. Officially, no prerequisite is required, but you need to have solid programming skills. You know how to design algorithm, flowchart, and having knowledge in calculus. So exposure to linear algebra and probability theory is going to be a plus and make your job easier. So this is a book that we are using. So I'm not going to click on this link because we don't have time to do that. So just click on this link. You're going to be directed to the course, to the textbook website. And in there, you're going to be seeing that, okay, about 170 different countries are using this textbook. There are lots of supplementary materials with this book that are available online. So that's a good textbook that can serve as an introductory to advanced, AI material. So it means that it is good for introduction. It is good for average proficiency in AI, and it is good for those that are very proficient and skilled in this area. We are not going to cover this book. This book is about, not all of it, but most of the chapters we are going to cover. So this is the book cover page, and it is about 1,100 pages. So we're going to be talking about most of the chapters in this book, but you are not going to cover every single page of it. And as I said, the textbook is not required. The notes are going to be available on the course Canvas page. Okay, course topic. We're going to talk about the search algorithm, about games, min-max search, and game theory, talking about the probability, basic laws of probability, Bayes network, hidden Markov models, and then decision making under uncertainty, and then we go to machine learning parts in this course, talking about decision tree and neural networks. And also we are going to take a look at the application in the area of AI and how we can use all those algorithms and techniques to develop an application in this area. Okay, now let's start the course. The first thing that comes to mind if you haven't taken this course before, so what is AI? So there are some definitions out there. There are several definitions. One from Wikipedia said that AI is intelligence demonstrated by machines, unlike the natural intelligence displayed by humans and animals. So basically, any intelligence that you can have with the machines, you can actually equip any machine with some intelligence that you can call AI. So this is a very general definition for AI. Having a machine with intelligence is called AI. So that's the simple definition. But what are the different strategies and definitions for AI from our textbook point of view? And what strategy we are going to take to implement our AI agent or machine in this course? So there are, so let me take my highlighter here. So there are different strategies that you can make a machine an intelligent machine. So first, you can make an intelligent machine by adding a feature so that the machine can think humanly. If a machine can think humanly, you can say that your machine is intelligent. Or you can make a machine with some strategy and with some science that can act humanly. And then you can make a machine with some of other strategies and resources available to you so that you can make the machine think rationally. And lastly, is that we can make a machine that acts rationally. We're gonna go through these 4 different categories and see which one is more feasible to implement or to make what's called an intelligent agent. Let's see which of these are a better strategy to go to make an intelligent agent. Okay. All right. First is thinking humanly. Okay, you want to make a machine that can think humanly. For this, you need to have the brain of a human as an information processing machine. So the human brain is your reference. Then what you need to know? You will require it to know the scientific theories of how the brain works. So you need cognitive science. And then try to understand the cognition as a computational process. You need to have introspection, meaning that try to think how human and we think. So that's very ambiguous. Predict and test the behavior of human subjects. So you need to have human subjects in your trial to predict what they're gonna be doing, and then they test their behavior based on your assumption. Then you also need to image the brain to examine the neurological data within the brain. So the latter 2, they are part of the cognitive science and cognitive neuroscience. So if you want to make a machine to do this, then these are to make a machine that think humanly, these are the requirements. So okay, since you're going to be dealing with the human subjects in your implementation, this is not an easy strategy to develop an intelligent agent. All right, second strategy is acting humanly. So for that, there is a very famous test that done by the Turing. it says that a machine can act humanly if machine can fool a human interrogator for sometimes for sometimes after the interaction. So that human interrogator or person cannot differentiate the machine from the human. So for example, here, that's a demonstration of it. So there is a barrier between the human interrogator that communicates with the human here and an AI system in here. He does not see which is behind the wall. Is it an AI system or human, behind? So if this interrogator cannot understand who is communicating with, is it a machine or is it a human? Then we can say that we are successful in making a machine to act humanly. So for that, to make such an intelligent machine, what do we need to do? We need to have the natural language processing. We need to have knowledge representation. We need to have automated reasoning and also machine learning. Turing predicted that by the year 2000, machines would be able to fool 30% of human judges for 5 minutes. It was 50 years before 2000 that he predicted that. But I guess that hasn't happened almost, during that time. But right now we are seeing some progress in that end. Okay, there are some criticism for Turing test, saying that making a machine that acts like a human, the problem is that some human behavior is not intelligent. So what are your solutions for such cases? Because when you design something, you need to know the reaction, and the behavior of the human in order to mimic that instance. But some of our behavior is not intelligent, and maybe we act emotionally. Some intelligent behavior may not be human. So the example can be, okay, so you might be able to multiply like 2-digit number by 2-digit number, right? But when someone gives you like a 10-digit number multiplication, 2 10-digit number, you are not able to do that, but the machine can do that. So this is also a problem. So you cannot tell your machine not to calculate that line number. This is an example, but that's the way to interpret it. Some intelligent behavior may not be human. Human observed may be easy to fool, meaning that, so if you make a machine, it is easy to fool the human using that without incorporating intelligence in it. So the reason is that a lot of your implementation is depend on your expectation. When you're talking with a chat bot, right, your expectation is to get some information regarding the software or platform that you are interacting with. And the other one is anthropomorphic fallacy, which means that we as a human tend to give character to any non-living being. For example, we can give a character to a tree, which is not a human. You can give a character to a wall. So we have a tendency to do that. And because of that, it is easy for us to get fooled easily. And then there is another argument, Chinese room argument. This is a very famous argument by one of the philosophers. They say that, okay, it's assumed that you are in a Chinese room and there are like multiple Chinese people in there that they are talking, and then you don't know Chinese, but you can communicate with them in this way. So when they talk to you, you can get that stream of data, and then you have predefined answer for each of those streams. So you're using a simple matching process. You can pick up a right answer for a given sequence of a string, and then you deliver that to the specific person that tells you. So the conclusion is that you don't know what you are doing. The basic things that you are doing is a simple matching process, but basically you don't understand that sentence in Chinese to communicate with the person, but you deliver the right answer to them because of that algorithm. So therefore, they argue that, okay, if you make some machine that act humanly, they do not necessarily have intelligence and might not be a good way to solve practical problems. And as we said, we can create intelligent machine without trying to imitate humans. Okay, the next possible strategy is thinking rationally. So we can make an agent, an intelligent agent that think rationally. So the strategy is to have an idealized or right way of thinking for your machine. So for that, you need logics. Logic is a pattern of argument that always yield correct conclusion when you supply with with the correct premises. So it started with Aristotle, philosopher and mathematician. He has attempted to formalize the rule of logic thoughts. Therefore, if we want to implement an intelligent machine that think rationally, we have to follow this approach, logicist approach to AI, basically. So it means that you need to describe the problem in a formal logical notation and apply general deduction procedure to solve it. So what are the problems with logistic approach? The first one is the computational complexity of it is high. Then the second one is that you may not be able to describe any real world problem and knowledge in logical notation. And a lot of intelligent or rational behavior has nothing to do with logic. So a lot of them. So what is the solution? For this, we need an agent that acts rationally. So therefore, we come to the rational agent. A rational agent is the one that acts to achieve the best expected outcome. Basically, you as a scientist are going to design a machine based on the delivery of the outcome. So you try to maximize the expected utility for your machine. So being rational means that. So in practice, utility optimization is subject to agent computational constraint. That's the only issue that your machine has. So in order for your machine to act rationally, you can, for example, have an optimization problem and tells your design your machine in the way that it finds the optimal point of that given problem. So, but in order to do that, in order to find an optimal solution for your problem, sometimes you need like an infinite amount of capacity, for example, RAM capacity, or it takes an unlimited amount of time to find the correct answer. That's the reason we say that maximizing the expected utility, meaning that most of the time your machine is able to produce the desired outcome, most of the time. That's where the expected utility is coming from. So in this way, in this strategy or methodology, we only concern about the decision action that are made, not the cognitive process behind them. So we only care about the result, in other words, not what is actually behind that decision-making process. And in this course, we are taking this way to actually implement our intelligent agent. So the advantage of this technique is that it's generality. So it means that it's very general. So therefore, it goes beyond explicit reasoning and even human cognition altogether. Its practicality. So it can be adapted to many real-world problems. And it's amenable to good scientific and engineering methodology. And it's also about philosophy and psychology, where you deal with human subjects. So you don't need to deal with human subject if you design your intelligent machine in this way. Any disadvantages? As I explained, the disadvantages of designing an intelligent machine in this way is that limited rationality, and that comes because of the limited resources that you have. Resources can be time, or can be, for example, your system capacity in terms of memory and time. Because taking an exact optimal action is not possible in complex environment. You're going to be seeing that, for example, for a given simple search algorithm, how many states you have and how much memory you need to save those states so that you can search through them. But there are different ways to tackle these issues, as you will be seeing next week in our first lecture. Okay, so AI connections. So in order to make an intelligent agent, what are the science or which science or discipline you require to know? Basically, we cannot have expertise on all these areas, but one thing to know that all of these areas contribute to making an AI machine. Philosophy is there, as you can see, we talked about that, making a machine that can think rationally. Then the mathematics is there, so you need to have logic, probability, and optimization kind of skills. Economics also is there, definition of the utility, decision theory. Neuroscience is there, you need to understand how the brain works. Cognitive science, so how to model human intelligence using computational model, linguistic, and so on. So these are the fields that require to make a perfect an intelligent agent. Okay, so let's take a quick look at some of the example of AI today. So one is the IBM Watson machine. So basically, as you can see from this figure, this is the Jeopardy game, actually Jeopardy game, that there are some human subjects and they're answering some question, and based on the structure of this game, they are rewarded with some money. And as you can see here, Watson is one of the participants. This happened in 2011. So Watson kind of was the winner for this game. I'm not sure if I have the correct link for this. Let's see.
What is Watson? Only IBM can bring together this on Jeopardy, developing a computer system personified by this name to compete on Jeopardy. Elementary? I think not. It's a very difficult task. But the correct response, in a sense, is elementary. What is Watson? Only IBM can bring together the skills and the investment capability to take on a grand challenge of this size. Watson is a computer system that we've been putting together that is going to advance the state of the art in automatic question answering. It requires critical thinking. It requires a whole lot more than knowledge alone.
So when people hear about this project and they say, well, isn't this just sort of Google on steroids? No, it is not.
It's always been a challenge to create computers that can actually communicate with and operate at anything like the level of a human mind. Under the hood in Watson is a natural language processing technology that's going to help advance the field. And Jeopardy is a great showcase for that kind of technology, because what Jeopardy requires is that the computer competes with some of the best humans in the world, minds that can very rapidly access a huge breadth of knowledge, deliver precise answers upwards of 85 or 90% precision, and deliver that with.
Okay. Have you guys been able to watch the video? Was it playing on your end?
I played for a little bit, yeah.
Yeah, it was playing.
Okay, so the links are given in the lecture slides. So please go through them and take a look at them. They are interesting. So let me go back to the lecture slide because of the connectivity. Some of you couldn't watch actually the video. So let me go back to the slide and finish this slide, because I wanted to quickly go through the, so not this one, to the virtual lab. All right, so this is yes, sure.
Could you state the page number so I can follow you? I can't see your screen. It is just black page.
Oh,
Black
really?
screen. Yes.
Okay. It is page number 16 right now. Everybody can't see this one, or everyone has problem. This slide should be the same. But I have updated the slide today. If it's a bit different, please download the latest version. So I updated these lecture slide like today. All right. So if you cannot see it, just open the slide and take a look at that. So we're gonna conclude this lecture very quickly. So the next example for the AI application is the Google self-driving car. Basically, it's equipped with a lot of sensors and computer vision to drive itself through the roads. So they've been working on this project, I guess, since 2011. So there's a video given in here. Take a look at that too. So computer vision and data interception, a lot of cameras, a lot of different sensors. So the other example of autonomous car or Tesla, I guess you guys all know that. And probably you have heard about the jump in Tesla share during past few weeks. It's kind of triple. All right. That's a big evolution, you know. This only Tesla could do this, you know, partly because we are not in crash right now because of all these great technology company that we are having in the US. And these company keeps the US, the stock market, alive. Without them, I guess the country have a real crisis during this period. Yeah, regarding this issue, I guess if some of you are in the stock market, you might know that. So today was the public offering of one of the Chinese competitors to Tesla in the US. The company name is Xpeng, I guess, Xpeng V. And then one of my friends said that you should participate in this IPO. And so when the price came out, it's supposed to be at $11, but for some reason they bump it up to $15. And then there is another Chinese competitor called NIO. They are also making electric vehicle. So their share is about like $20 right now. They're producing about 50,000 color cars. per year. But this new company that came to the market, stock market today, they are just producing 20,000. So logically, it was telling me that, okay, the $15 per share is a normal price. It's not something that is going to be jump up. So I did not actually participate in the IPO today. And the price gone up from $15 to $25. So it means that if you, for example, put like 150K in the market, right away you could get 250K, like 100K, you know. So that was a big, wrong analysis from my side. So, and I don't know that because logically it doesn't make sense for the price to go up higher than the other electric vehicle maker, since they are producing more vehicles. So their share is at $20 and they are like more experienced than this company. But I don't know, probably the human emotion kind of contributed to the price so that I couldn't predict that. So for also making AI machines, sometimes we can include all of the contributing factor, like human emotion. And so that's going to be one of the challenges. And just for your information, so if I, for example, today I put like 150K, I could get like 100K, $100,000, right? And guess what? How much do I get for teaching this graduate course at CSCI? So I spent like one complete semester, and they pay us about like $5K, $5,000. You know, sometimes stock market is good, but sometimes discourages people from working. You know, and this is bad. So you say, okay, just doing one trade, you can earn that much money, and you have to put a lot of time and resources in doing something else. So it's possibly the case for many people when they get into the stock market, they know the stock market and they see some sort of like unfair situation. Most of the stock, like 5 tech companies, they jump about like 300% during the past 6 months. So anyone invested in those is gonna be a winner now. All right, I guess I have to ask this question from Kyle later after the lecture, because he's working on with other industry, asking him why the stock of this company gone up this much. All right, let me complete this slide, and then okay, so the autonomous vehicle, electric car, and then the next application is natural language agent somehow. So speech technologies, you can see the Google voice search in your computer, or text to speech synthesis, or machine translation. When you put text in Google, it can translate it for you right away, and most of the time it gets it very accurately. And still we are progressing in that end. And then the other application is OCR, handwriting and recognition. And then we have face detection for your when it comes to consumer cameras or Apple iPhoto. Then we have visual search. You can use Google Goggle to search a given pattern in the internet. And then vehicle safety system also, they have like a lot of visual vision technology integrated in them. For some reason, again, I'm missing the website. All right, okay. So I guess you guys know many of these applications. So math, games, and puzzle, please go through these slides. And if you want to go through all of this, it's going to take a lot of time. Go through them, take a look at the examples and the links given in the slide to understand what the application are. And finally, the robotics application that we may focus at the end of this course, how we can apply AI into robots, how difficult it is, and what are the challenges, what are the good strategies and algorithms that we can incorporate in your robotic system. Okay, so this is an introduction just to motivate you for this course to take this material more seriously and with enthusiasm, just to encourage you. But I guess all of you guys know the application of AI in our life today. Okay, let me stop sharing right now and check. Time is 8:20, and so it is very simple. Let me go through the virtual machine, how to connect to it. So in case any of you is not comfortable working with the VirtualBox or Linux, or have a dual boot system on his or her computer, can use the virtual machine. Let me just so this. Let me share that very quickly. It's not going to take long. Okay. All right, so let me share that. So this is the window that you are going to see on your machine. So there are some instruction how to register yourself in the system. I actually added all of your names and email addresses to the system. So once you follow that process, you can get your own virtual machine. So once you are, can you see the virtual machine page? I mean, virtual lab page, this page? Yeah. Okay, yes. Perfect. So I'm gonna make this quick. So there is an icon, the blue icon in here, the monitor. So you just click on it, and then there are two options available to you. You just click on the second one, connect via SSH. So once you click on that, okay, it's asked me to set the password. Okay, so there are some. So you set the password. Unfortunately, this setting password process is going to take a bit of time. So once you do this process, then you basically set the password for your virtual machine. So every time you SSH to your machine, you need to remember that password, because the system is going to ask you that password before you connect to it. So then you will be connected to your machine. Okay, you guys can see this one, the SSH comment here at the middle of the page?
Yes.
Yes.
All right. So there is an SSH command. You just copy this one. You click on this, and then it's going to be copied into your clipboard. You say done, and then you go back to your terminal. If you are working with Windows machine, you can go to PowerShell, for example. Let me share that one. I guess I need to use the advanced share option. Portion of the screen, okay. I'm going to share this portion. All right. Okay, so right now I am on my PowerShell. This is a Windows machine, and I assume some of you might have Windows machine. So you can go to PowerShell. If you have Mac, you can also go to your terminal just by searching terminal in the search menu of your Mac machine. Then you simply come here and then copy the SSH in here, and then you click OK, and it's gonna ask you the password that you have set at the previous step. So once you've done that, basically you're connected to your machine. So my machine right now is dolphin@ml REF VM232850. So this is my machine. And here I am in my machine. So if you connect to that, there's gonna be something that may be strange to you. So there's a base in here. This is the Anaconda that installed on the machine. So okay, so if you want to deactivate that, you can deactivate the machine. Deactivate. Let me see if I have the correct spelling for it. Conda deactivate. Okay, so yes, that's correct. Okay, so you can deactivate that. So if you are here, right? If you are at this point, then if you type like to get the Python version, just want to tell you what Anaconda do. If you type the Python version, you see that there's no Python there. And if you activate the Conda, then you're gonna go to this environment. Now, if you type Python version, then okay. If you type Python version, it's gonna give you the version of your default Python machine, which is 3.8. This is not the version that we want. So we have to activate the Python packages that have installed for this lab. So for that, we have a command in your lab. If you go to project 0, sorry. So this is the command. So you also should use the same name in case we're gonna be addressing the same thing. So you basically activate this environment. You create that environment using this command. And then once you create it, then you need to activate it. So we say source activate COMP-569. So basically you come here and says source activate COMP-569. And then as you can see here right now, we are in this environment. So we change our environment to a new one where different version of Python is. So if you see here, right now the Python version is 3.6. So this is the Python version that we actually need. So how this was created? Using this syntax. So we actually installed Python version 3.6 using conda. So you say conda create -- name COMP-569 Python equal 3.6. So once you enter, then you create that environment. But in the virtual, all these virtual machines, this is installed for you. So once you get to your machine, all have been set and ready to go. But if you want to use your personal machine, then there are several steps that you need to do. The first one is to go to the Anaconda website just by clicking, I guess, on this link. You come here, and this is the version that you need to download. So in Linux environment, you can get that file using this one, that wget http. You can copy this and paste on your machine, and then you download that, and then use a bash syntax here, and it's going to install the Anaconda on your Linux machine. And once you've done that, you activate the Conda environment, and then you get the version to know what version it has. And then you create your new environment for this course, which is Python 0.3.6, and then you source it, and then you enter your environment and you're ready to go, and then execute whatever Python program you have. This is as simple as this. And there's another document that tells you how to copy files from your host machine to your server in the virtual cloud. So all of this command I have entered over here in this document. This instruction document given at the beginning of your Canvas page virtual lab menu. So if you want to copy, for example, a file from your computer, this is the path to your computer. And how about this? What these are? These are actually the part of the SSH command that you get when you click on your machine in here. So in here, when you want to connect to your machine, so you see all this. So you said SSH through this port, and this is where you need to go, and then you need to add some path to that virtual machine in the server. You need to specify the port number. And one thing to note in here is that in this command that you have to copying the file, this P has to be capital. If it's not capital, it doesn't recognize. So SCP, secure copy, need this to be capital. And then this has to be your port number that you get from the SSH machine. And this is going to be your directory from your host machine. And this is where the file is going. So this is part of your SSH, and then you have to add the directory to it to tell, okay, this is a machine, but where in this machine the data should go. So this is the way to copy it. Copy a file, copy a directory. Now you have done your project, you run your project, you update your source code, you need to submit those to Canvas, right? But they are all available on the remote desktop or remote server. So what you need to do there? So you need to copy that in your host machine and from your host machine to Canvas. So this is the syntax for it. So copy a folder directly from a local machine to virtual machine, but we have from virtual Linux server to your local machine. So in here, you first give the path to your virtual machine, and then you give the path to your local machine. So some screenshots are given in here. Just take a look at this screenshot as an example, and then you are good to go. There's nothing complicated. Two things you need to do. SSH, set your password, get to your machine in there, and then do your work in there, update your source code, make sure that everything is working, copy that back into your host machine, and then upload it to Canvas for your project. So if you're working in a group, then probably some of you might work in the virtual environment. Some of you may choose to work on your personal machine. So then you can learn from each other, which is better. Okay, any question? Let me see. I guess we have some question in here. Let me stop share. Sorry, guys, I didn't want it to make this lecture this long. I know it might be a bit boring. Okay, chat. Okay. This project is due September 2nd. If this date, I don't remember by my heart, if this date given in the table, yes, and then there should be September 2nd. Let me take a look at the syllabus very quickly. So all due dates have been given in the syllabus. So I go to this table, I take a look at week 1, there is no due date. And week 2, project 0 is due September 2nd, yes. The answer is yes, it is due September 2nd. Any other question?
Excuse me, Professor. So just we can work with the virtual lab for a certain amount of time, or like 2 hours.
So in case you reach the limit, just let me know. I increase the limits.
Okay.
Normally, it is a good practice when you done your work with the virtual machine. Just stop that, because they're gonna. I guess it's gonna cost the university.
Okay.
For each hour or each second that you run the machine, it's gonna add some cost.
Okay, thank you.
So just stop it. So as soon as you stop it, it doesn't go that beyond. But if in case you pass the limit, just let me know. I right away increase the limit.
Thank you.
No problem. Any other question? Thank you very much, everybody, for your participation in this meeting. Hopefully, for the future lectures, we're gonna make it a bit shorter. I know you guys might be a bit bored with this one, but I promise you that the next one gonna be possibly shorter. And please feel free to ask me any question you have through the discussion board. And if it is a bit more private, send me an email and we discuss it during the office hours or any other time that you are available. Thank you and have a great night.
Thank you,
You
Professor.
too. Thank you.
Thank you.
Thanks.
Professor.
Have a good night, everyone.
Thank you.
Have a good night, everyone.
Bye-bye.
Thank you.
Bye.
I do have one quick question for you, Professor. Where can I find the information to set up that
Lab?
The creating
Anaconda?
the environments for Anaconda?
Oh, okay. So once you go to the virtual lab page in Canvas, there is a link for the instruction. It tells you, okay, for the instruction to set up the lab, click on this link. So once you click that link, there's going to be a Word document showing all the steps.
I have a question.
Okay, thank you.
Professor, I have a question. That
Sure.
is project zero individual or it's a